Gil, this place is fantastic. Now, how did you get to this point?
Well, for 48 years I've been doing my hobby, and that's hot rodding.
Absolutely.
And we've got a lot of neat things going on in here. Over here, we've got a pro stock truck. It's a V8 diesel Duramax.
Drag racer.
Drag racer. Right here, off-road. V8 diesel Ford.
Great.
And this is the world's fastest pickup truck. Inline 6 Cummins in a Dodge. International record at 222 miles an hour.
Unbelievable. And this one's the one that will tow the trailer to the salt flats, right?
This tows its own trailer.
That's great. All right, now what do we have here? This is a pretty interesting looking truck.
Well, this is the Banks Sidewinder D-Max Type R for road race. V8, 700 horse diesel, run against the Ferraris, the Porsches, and the occasional Corvette.
With a diesel. That's great.
This is an example of a ground-up Banks project. We started with a bare concrete floor, designed and built the chassis, designed and built the powertrain, clayed the body, pulled molds off, and built carbon fiber panels.
That's incredible.
And now we're in development on this, and we'll be road racing this up to 25 hours in one race. We want to take every diesel that's out there, push it to its limits, then we know better than anybody what to do in your pickup truck on the street. We've done offshore racing with turbos as well. We had the first street-driven car at over 200 miles an hour on the cover of Car and Driver with one of our twin-turbo small-block Chevys.
Well, this is really great. This is all pretty serious stuff.
This is serious stuff.
Now, to design and test all this, have you do all the design right here in-house?
Everything is in-house at Banks. Let me take you to the CAD room. Sam, this is a drafting room as far as Bob Robe is concerned. After 28 years here, he's the draftsman. The younger guys are the CAD designers. They're doing it in the computer. James is designing an air intake system, a Banks Ram Air. This one is for the Duramax diesel. Essentially, we digitize the truck, load that in the computer, and then design through the truck. He's working on an inlet duct there, a cold air duct, that red item. May I see it, James? And this is how it will look in finished form. And what we do is we take the CAD file and we run it to our rapid prototyping machines, and we actually build this part. Now, it's built in pieces and then cemented together, but it will function as the finished part.
That's great. So you do all this in-house, you design it, you do a prototype right here, then you can manufacture. This sure beats banging around on metal on a bench for 3 weeks.
It does, and we can go right with this piece to the flow bench. We can flow it. We can determine the position of the MAF sensor, get everything proper so that it runs properly with the engine management.
It all has to work in concert. What about the electronics?
Well, we do all of our electronics in-house. Schematic design, circuit board design, software, manufacturing, programming, and testing, all in-house.
Incredible. That's really incredible. If you do it all right here, you can control it all, and that's the big message, you know, all working together in harmony with guys with the same thought process.
Exactly. All our pieces work in concert with each other. The air intake, the exhaust, the tuner, all of it.
What's next?
The engine room.
I can see you've done some things here. Tell us about what you've done to make this engine live longer and go faster.
Okay. Other than clearancing and balancing the engine, we've also knife-edged the crankshaft counterweights to cut down turbulence. And we've CNC machined a dry sump oil pan that we've designed. It's about 2 inches thick, and it has bridges that go across the main caps and reinforce the main cap so you can keep the crankshaft in the block at high cylinder pressures.
Now, looking at the dimension of that, it also strengthens the block, too,
It strengthens the entire lower end and gives you a greater ground clearance.
You've done some cylinder head work?
We CNC the cylinder heads, and we've also, we get into doing our own intake manifolding a lot of times. On the Cummins engines, we machine the manifold right off the head, replace it with ours. This is one of the 2 manifolds that fit this V8. Everything matches at the ports. It's O-ringed, no gaskets, to the cylinder head.
Okay. So it gets back to what you said. If you're going to make power in a diesel, you've got to address airflow.
If you haven't addressed airflow, you have no business putting additional fuel in a diesel.
There you go.
It's that simple.
And that's a beautiful manifold.
That's a sure way to disaster. I love this thing. Started building these in the late 70s. We had the first magazine test at over 200 miles an hour with one of these.
That's great.
This is a refresh of that design. Fuel injected, big throttle body, twin turbos, dual wastegates, serpentine belt setup. And this plenum, there's some magic stuff goes on in here in terms of managing the air when you shut the throttles. No turbo lag with this thing. 1,115 horsepower at 6,800 RPM, and it makes over 900 pound-feet of torque almost everywhere.
And it's very streetable?
Extremely streetable. I've got one of these in my little black Chevy. We call it the Rat Rod shop truck.
And that's amazing.
It's a ride.
And you got a great high-speed dyno here, don't you?
Our dyno will go to 12,000 RPM. That's the high-speed dyno cell. The high-torque dyno cell will go to 3,000 pound-feet of torque. That's our diesel engine dyno cell. And they're fully instrumented. I know exactly what's going on in every system of that engine.
Well, that's great for real consistent horsepower. But now we've measured the flywheel horsepower of this or the flywheel horsepower of the diesel motor.
Exactly.
It's time to put it in the vehicle and then run it on the chassis dyno.
Yeah,
huh?
ultimately what really matters to the guy is what's the power at the rear wheels.
Right.
But we take it one step further than that.
All right.
We're going to go look at it.
Now, what's this rig? This is pretty elaborate.
If you're going to test an intercooled diesel, you got to have highway airflow on your chassis dyno.
Okay.
Otherwise, you can't develop intercoolers, let alone have consistent exhaust gas temperatures, cool the radiator properly. This thing makes 30,000 CFM of airflow. It's 15 horsepower at 60 miles an hour.
And even underneath the truck?
Exactly.
That's great. Well, this is pretty incredible, being able to have your dyno room outside here.
This is a 1,500 horse chassis dyno. The rolls are Gilbert belted together, so it drives off both rolls. Now, I want to run on the chassis dyno continuous, and I want to have it repeat. So on the wall back here, I've got two blower systems. They blow through those 8 pipes under this slab. Air comes up, cools the tires, cools the eddy current absorbers.
Right.
So you never have tire slip that skews your horsepower reading.
Repeatable.
Exactly. And you can run sustained chassis dyno setups.
That's great. Well, that's really incredible. Now, you're going to show me something trick that you did.
Well, basically, people don't drive engine dynos and they don't drive chassis dynos.
Right.
They drive the truck. So what we do is we put the dyno room in the truck, all the data acquisition, then we go out in the real world and we measure the actual performance. We measure our performance, we measure our competitors' performance. Right. Same truck, same day, same driver.
So the deal is, when you buy something from Banks,
yes,
you take it out of the box, it's going to perform as advertised because you've tested it in the real world.
Yes, our numbers are fact.
That's great.